The sum of the first n terms of a geometric sequence can be found using this formula you see here, that S sub n is equal to a sub 1 times 1 minus r to the n, and that divided by 1 minus r. So the S sub n is basically a notation for the sum of the first n terms. A sub 1 is your first term, and r is the common ratio. And of course, n is the number of terms. One requirement is that the common ratio cannot be 1, but otherwise it can be any other number. So for example, if I want to find the first 6 terms of the geometric sequence of 128, then 64, then 32, you can see that each time I'm dividing by 2, or I'm multiplying by 1/2. So the first 6 terms, I guess the next one would be 16, and then 8, and then 4. If I want to do this directly, my S6, the sum of the first 6 terms, would be 128 plus 64 plus 32 plus 16 plus 8 plus 4. And you can put that in the calculator, but you should get 252. If I'm using the formula, I would say that the first term is 128. My common ratio is from 1 to the next, I am basically multiplying by 1/2 each time. So I'll be doing 1 minus 1/2 to the 6 divided by 1 minus 1/2. Which, so if I put that in, 128 times 1 minus 1/2 to the 6. All right, and then divide by 1 minus 1/2. And I get 252 again. So you see in this case, I get the same answer either way. For a small number of terms, you may just add them up yourself without the formula. But if I ask you to find like S600, the first 600 terms, the formula would be much better. All right, let's try another one here. Find the sum of the first 5 terms. So again, we can do this directly by 10 plus 30 plus 90. It looks like from 1 to the next that my r is going to be 3. So the next term would be 270. And if I multiply by 3 again, my next term would be 810. And that adds up to 1,210. But if I'm using the formula, that would be my first term is 10. And then 1 minus 3 to the... see here, the first 5 terms, so 3 to the 5th over 1 minus 3. So in the calculator, that would be 10. Let's try that again. 10 times 1 minus 3 to the 5th divided by 1 minus 3. And I get 1,210. Well, in the case that you're taking an infinite number of terms, like if you want to add up every single possible term that ever existed for this sequence, it's actually a simpler formula. It comes out to be a sub 1 divided by 1 minus r. The requirement is that r has to be between -1 and +1, but otherwise it could be anything in between there. So for part A, I see 125, 25, 5. My a sub 1 is 125, and my r is going to be, I take one term divided by the previous. If I simplify, that simplifies to be 1/5. So the sum of this infinite sequence, would be 125 divided by 1 minus 1/5. So 125 divided by 1 minus 1/5. And I end up with 156.25. So have you noticed that it doesn't necessarily come out to be an even number? And that's fine. And next one, 128 plus 64 plus 32. The first term is 128. My R would be 64 over 128. Looks like 1/2. So the sum would be 128 divided by 1 minus 1/2. So that comes out to be 128 divided by 1/2, or 128 times 2. So 256. And this last one, if I say I want to take this fraction, this decimal 0.8, where the 8 is repeating, I want to write it as a fraction form. So think about what this 0.8 with the bar over it means. This really means 0.88888, and so on. That first 8 is really 8/10. The next 8 is 8/100ths, or you can think of it as 8/10 times 1/10. The next one would be 8/1000ths, which is 8/10 times 1 over 1/10 squared, and so on. You see that we can think about this as a geometric sequence where a sub 1 is 8/10 and my R is 1/10. And so the my sum of this would be 8/10 divided by 1 minus 1/10. So that'll be 8/10 divided by 9/10, or 8/10 times 10/9, and that comes out to be 8/9. So that tells me that 0.8 repeating is the same thing as 8 over 9.